Hey guys, happy to see you, or at least you can see me and hear me. If you have any questions, write to the chat and I will answer questions right after I finish. So the topic of today is monitoring machine learning stacks. So I will briefly introduce myself. So I'm the lead machine learning engineer at a German internet bank. It's called DKB. And before I used to work at Zalando, which is a huge e-commerce, fashion e-commerce platform in Europe. So you can tweet me if you have some questions or want to get in contact afterwards. Okay, so let me introduce the problem to you I'm trying to solve. So the issue in monitoring is that it can be very hard with a machine learning stack to detect if your service quality dropped. So, for example, if you have any machine learning service, we can take here a recommendation service. And let's say the recommendation service gives you articles in the same style. So here you see the articles. And as long as you get a response with articles from your recommender, it can be very hard to detect that these recommendations become worse. And this is the same for many ML services. As long as you get a response, it can be very hard to detect that the quality of this response got worse. So today I will show you what causes these problems. So why would the output become worse? Is it really a big problem? I will pitch you a solution and I will show you a case study where I implemented the solution and what I learned during the implementation. Okay, so why do we have a problem with current monitoring? So how do we typically monitor a machine learning stack? Typically, we monitor it like any other service. So we have the 4 golden signals of Google SRE. So we look at latency, how fast is the application. We look at errors. We look how much traffic it's getting, and we look at saturation of resources like load, CPU, etc. So you have a bunch of tools to the right that you might or might not use. These are all very good tools. So you should definitely monitor an ML stack also for these 4 golden signals, but this is not enough. There are additional problems that can occur in a machine learning stack, and I will show you now what can happen. So to illustrate the problems that can occur, I gave you an example service here. This is how many ML services could be considered. Just bear with me, I'll walk you through the components. So you have a model that is wrapped by a service, some additional code on top of the model that calls the model and also typically applies business-related rules. For example, on availability of products or certain deterministic steering rules that your business imposes. There is model configuration that contains information about these business rules or just model parameters. On the left, you see a client. Here it's an app, but could be anything, another service that calls your ML service. And doing to the processing of the request on the right-hand side, you see external services that often you might call during the processing of your request. So for example, to get meta information for your request processing, or to call another machine learning model to get a prediction for part of your processing pipeline. And to the right-hand side on the bottom, you see what many people still do, unless you have a live learning system, in which case it would look a little bit different, but similar problems. So you have the data that is typically extracted per batch, and then the training process, and the model gets updated and deployed. But if you have a live learning model, similar process, except the data comes into the live deployed model. So now, what could possibly go wrong during the processing and creation of this request? So one thing that can go wrong are bugs that the client releases. So the client sends you data, for example, user IDs that you need to retrieve certain properties of the user as input to your model. So there might be a bug where a client suddenly uppercases a case-sensitive identifier, And for example, it could happen that this only happens to the iOS app and not the Android app. So not 100% of your traffic is affected. And then you will actually go blind for a part of your request and the model will get empty inputs. This is not something that will create an exception because an all uppercase identifier is legal, but you will not see this in the logs. So these people will suddenly get no personalization, but it's hard to spot. And by the way, all the bugs that I'm telling you about and the problems I have actually seen in the wild, so they are not conceptual. What can also happen is that the client reuses your call and suddenly calls it from another part of the application without telling you, with a different sort of distribution of the data. You also would like to be aware of this. This can also cause problems. Okay, so the code of an infrastructure can have a bug. So one example is you release and you made a bug in your own code base. We had a case where we had a copy and paste bug and it pointed to a wrong core of the database, a similar model, but not quite the same. So the quality dropped quite a bit because the return was mostly empty. But again, there is no exception being logged. And it's a permanent problem. But it was not visible because it's a slightly similar algorithm. So again, the response is not empty, but it's hard to spot. Next problematic area is the model itself. So it could happen that the training data, the input distribution changes. So your training results in a worse model, and that could be permanent because for some reason, whatever use as a data extraction has a bug, or the data itself changed suddenly, but only for the offline part. So you release worse models, but the models still give results and they don't look unreasonable, but they are on average worse. So it would also be great to detect this during the update process of the model. Next risk area is an external service that you're calling. So for example, we had a case where we had an enrichment service for meta information, so something that you feed into your model or into your business rules. For example, you might get prices, or you call another machine learning model that gives you a personalized size recommendation. So if any of these external services degrade in performance, so because, for example, another machine learning service like a personalized size recommendation might have a bug, or we had a case where we switched from one enrichment service to another, and in the other enrichment service, one of the fields that we used to filter on was less filled. So in the end, you filter out more of your return values. So in the end, your model is the same, but the user actually sees less recommendations. So you also want to see if one of your dependencies that you call maybe leads to you having worse performance. And last but not least, configuration can also cause issues. So I call this configuration. So this is anything that either applies to the model, so model configuration, or these business rules. For example, you want to say you don't want to show discounted articles or only articles with a certain availability. You can have corresponding rules in your domain. So here are possible bugs that a user makes a mistake, applies an overly restrictive rule, and it's hard to see, and they send it live, and suddenly a lot of your recommendations get filtered out. Or maybe a rule is actually fine during a certain part of the year, for example, non-sales season, that during sales season, one of these configuration rules becomes problematic. You also would like to see that this is happening. So as you can tell from my examples, that these possible issues are not unrealistic. They happen, and they happen a lot, and they degrade performance quite a bit. So it can be that we spend months on a machine learning project to improve accuracy by 1 or 2%, but then we release these bugs or just data shifts or any of the aforementioned examples, and they degrade performance by much more than these 1 or 2% where we spend a lot of engineering efforts and also money to improve. So I would say that it would be very important that we get awareness of these issues and can take them when they happen. Okay, so what can we actually do about it? I'm about to propose you a solution or a partial solution to this problem. So I would say for machine learning services, we need to redefine the response qualities. So typically, our definition of a successful response for a normal microservice is it should be fast and there should be no error. So our SLO is often, let's say, in 95% of the cases, we want to answer in less than 200 milliseconds without an error. Let's say we extend that and say we still need to be fast, we still need to have no errors, but we also need to be successful according to the business case. So your ML business case. So to take an example, if we have a personalized recommendation on an e-commerce homepage, instead of just saying this thing has an SLO or SLA of 200 milliseconds, we could say that we want in 65% of the cases at least have 4 articles that should be personalized in this amount of time. So basically building on top of the previously purely technical SLO. Okay, so basically, where do you measure? Let's take the same diagram where I illustrated the risks before. You measure at the blue dotted line, so right before you return to your client. I also wanted to present you some alternatives that I could have decided on for a solution. And I sometimes get asked, why didn't you do this instead? So I wanted to show you why not. So alternatively, we could also decide to monitor user behavior with the actual user interactions. So let's say we return our recommendations and just have a look how much users click. Why is this not as useful? Well, there are some downsides to to measuring and detecting user behavior. So for once, the user behavior typically doesn't have all the necessary fields that you need to really monitor and map back uniquely to a stack or to a version of the stack during the deployment. The next drawback is that these user behavior events are typically less frequent. So many things have a click rate in the small 1%. They are way more noisy in their reaction, and they're typically less reliably tracked. So even when you have a 10% drop, because you released a small bug or the client released a bug, this is very hard to see in the user reactions. So actually it's easier to see at the point where you return that something dropped by 10%. And the last disadvantage of taking user actions to detect these issues is they're often not retrievable in real time. Let's say you want to use the Google Analytics logs, and they require more effort for integration and maintenance. So it would be nice to have them, maybe have them additionally if you have time, but they are not the most suitable to detect the problems I just described. Okay, and there's a third alternative where we could measure. We could measure around the model. So this is what many applications offer. They have like model monitoring to model the model inputs and the model predictions. This is also not bad, so you could do this additionally, but it will have the disadvantage that anything that happens after the model, so for example, any business rules you apply, any processing, anything that happens afterwards would not be covered. So go ahead, do this also, but I would have like the advantage of also covering everything that happens afterwards, so I can have a real sense of what I'm returning to to the user. But they're both useful. Okay, so how do you select such a metric to measure your return values? So it depends on what your machine learning stack actually does. So you have to choose it on your own based on your business case. The good news is that you don't have to actually capture the real quality of what you're returning. That's typically quite difficult to capture, but you just need a quality indicator, a simple heuristic that probably goes down if one of these problems happens. So a simple heuristic is fine. What are the criteria to select such a heuristic that I can at least tell you to look at? So ideally, they should be comparable across models. So don't use anything super model specific. They should be simple and easy to understand. So let's say it drops by 10%. You should get a feeling how bad this is. So don't use anything super complicated where no one knows if it drops from 90 to 70. Is this as bad as from 70 to 50? You should have ideally the product manager, every engineer, and the machine learning scientist, they all understand what this metric means. So simple heuristic. It should be collected in real time so you can actually effectively alert on it and not something that you run on demand. And you hook it up to your monitoring system so you can actually use it to define alerts on. Okay, so let's have a look how this thing went in practice. I used to work at Zalando, which is Europe's leading online fashion platform. So maybe you don't know it. I noticed that some people from North America don't know it. So it's very huge. It has 7 billion revenue and 31 million active customers in 2019 and 17 countries of Europe. And I used to work in the recommendations team. And they had dozens of business cases, both for the website, the apps, and emails, with many algorithmic stacks and quite a heavy load, 4,000 requests per second, and low latency requirements. So I was attempting to measure all of this. So interestingly enough, I could use just a single metric for all these use cases that we were serving. Since the recommendations were created from a logic that looked like this. So there's always a sequence of configurations. And when a request comes in, give me 20 recommendations. There was a best configuration, let's say a personalized recommender with certain business rules. We would attempt to get 20 recommendations from this configuration. If it didn't work, it only hit 10. We would try the next best one, for example, an unpersonalized recommendation engine with certain filters. If this was enough, you could return. If it's not enough, you go to the next configured configuration and so on, till you arrive at the worst one, typically some fallback like popular articles. And from this knowledge, you can derive a simple quality metric. You could say that we consider it a good response if the top 5 positions are from the best configuration, so the first one. And it's a poor response if it's less than 5 articles or we have at least one fallback, for example, popular items among these 5 recommendations. So this is quite simple. And how do you implement such a thing? So you actually know how you can practically put what I'm telling you into production. So you can do it with simple metrics. So on every application, you have a metric, whatever metric library you use, which on every request, as it goes out at the very end, you say, you evaluate your metric. Was this a good response? Was it a poor response? And then you increase the corresponding counters and you increase the counter for the total response. And you do that per business case. And then you have a polling tool, whatever you're using. We have an open source polling tool called Zmon, but use your corresponding in-house solution. And that polls all instances that are deployed and calculates the overall rate For example, for this use case, we might have 52% good and 9% poor, and then we can define an alert. So if it drops below 30%, an alert comes up on the board. And then you can display it in Grafana, and it will look like this. So here you can have a drop down of the use case. I anonymized it here. So you have all the possible use case, all emails, all on-site locations, and you have the real-time quality indicator and the real-time traffic. And if it drops under a certain threshold, you can have an alert on your board that someone checks. You can also look at longer time frames. So for example, here is 3 days. The line on top is the share of good responses, close to 100%. And the line on the bottom is the share of bad responses. You see at night, it always gets a little bit noisy because there's more bot traffic. And you can use these long time ranges for an analysis once an alert comes up. You can even use it for deployment. So you can detect bugs in your own stack. So you would deploy model changes independently from code changes. So the assumption is that your model stays exactly the same and you added some code or you affected something. And then you have a canary deployment where you have 2 stacks live at the same time and you switch over the traffic and you measure your quality metric on both stacks. And since we didn't make any changes to the model, we would expect the difference of the 2 stacks to be 0. So this is actually quite similar to an AA test. So there should be no difference. We can plot this. And here you have our whatever 30, 40 business cases that the stack is serving with different algorithms. And here each line is one business case. And this is the deployment time. So it was 30 minutes deployment. And one stack, let's say, has a quality of 80% good, and the next stack has a quality of 79%. So this monitor would show it as -1, the difference between the two. So you don't have to remember all the levels of all the different use cases. You just know if there was no bug introduced, then the difference between the 2 stacks that you're deploying should be 0. So you look at this monitor, and if any of these lines are structurally below 0, you can just eyeball it. You, of course, could also do a statistical test, but we're just looking at it. And this deployment has no bug. So 1 or 2 of the business cases are a bit noisy because they don't have that much traffic. But you can observe them over time. And here there is no bug introduced and you don't have to roll back. Okay, so now I showed to you that we do have sometimes quite severe problems that are impossible to detect with normal monitoring. And you can add quality metrics to detect this issue. So I showed you the problem, I showed you one possible solution and a case study, how I verified the solution in a really big company. Yeah, so the takeaway is you should monitor quality metrics, and they can be very simple and they allow for real-time monitoring. They're very easy to integrate with existing tools, your existing metrics, and they will help you to detect problems that are really hard to spot and sometimes even permanent. Okay, that's it. You can ask me questions now. Okay, first question. How do you evaluate how a change in a service using a model is affecting another service? Okay. How can you evaluate how a change in a service using a model is affecting another service that is using the output of the former model as the input to its own model? I guess the same. It doesn't matter what the client is. If your quality metrics dropped, it probably became worse and you should investigate. It doesn't matter if the downstream user is just a client, a normal customer client, or if it's another service, same rules apply. Any other questions? Can you get the slides of the presentation? Yes, I don't know how. I will give them to the organizers. I guess they will tell us all how. You saw in one of the slides that Zalando is using Grafana as a monitoring tool. Any other recommendations? That's, I guess, general question. Your opinion is as good as mine. I found Grafana okay, but it's lacking sometimes if you want to have something like box plots or something like this. If you monitor distributions, but no specific endorsement. What's the engineering response to seeing drop metrics? Yeah, that's a good question. Sometimes it wasn't clear who should investigate this, but it's definitely engineering task because usually something went wrong with engineering. You would dig on the root cause. So what was changed? You would check the typical things. Did you have a deployment? Did it only affect a specific business case that you're having? So it could be that the client had a deployment. You're looking at the long-term range, how this metric typically behaves. Is it typically that jumpy? If not, you just figure out basically where did the change happen? Typical debugging. What monitoring tools do you use or recommend? We use Zmon. I have no special endorsement. That's a general question. So typical software engineering monitoring tools, whatever your company is using, normally you can pick. You already have something in-house. Your recommendation as something that is beyond just watching for model drift? Question by Lynn. Yes, definitely. Drift is one of the issues that can happen. You can have a threshold if the quality drops slowly over time due to drift, but it's just one of the root causes. I saw bugs and unaligned change in the clients and this kind of stuff, or bad configuration that someone faultily applied, where much more or complete changes in the data that were a bug. For example, a very famous change that caused a lot of money lost was someone switched a feature from milliseconds to seconds. So this is a sudden drastic change, not a drift. And yeah, yes, watch for more than just drift. SageMaker model monitor. Yes, that's one of the things that's wrapping around the model. So I had this slide here. Right? So SageMaker model monitor, I also checked it out earlier. It definitely models slightly different than I do. It's this distribution on the data inputs. And I couldn't find if they're also modeling the outputs. If there would be, then it would be here. But it's not covering your whole box here. So if you do anything after the model, it wouldn't be covered. So bugs you introduce or bugs if you call another service afterwards wouldn't be captured by a SageMaker model monitor. But if you have no other business rules, it might be suitable. You would have to check. Yeah. Okay, any other questions? How can you detect model drift, monitor the data distribution? Yes. So you want to have basically very good isolation points. You want to monitor your input data and have one check there. You want to model your output from the model. That's what I'm proposing here. So you can even go more fine granular and model the distribution of scores if you have something like this. Yeah, you want to have isolation points at each step. So ideally, you also have an isolation point here if you see this pointer before the training even starts, where you monitor the data distribution. Do that as well. But that's in addition to what I'm proposing. Okay, any more questions? If not, feel free also to get in contact with me directly. Okay, then if there are no more questions, oh, thank you. Thank you too. I'm sad I can't see you or talk to you. Maybe another time and then we can all get coffee. Thank you. Compute distances between distributions. No, you don't. How to raise a flag. So here in this case, you just have thresholds. So if you're below 30%, for example, you just raise a flag. So you don't need to compare distributions in this example, but you could also compare distributions if you wanted to. Okay, thank you. Is it possible? Okay, one more question. Is it possible to monitor the joint distribution of the input data or just the univariate distribution? Okay, this is something I'm not covering in my talk. So as you could tell, I'm monitoring the output of the model in the stack, not the input of the distribution. You can. So I myself in my applications, I started with just the univariate distributions. This was enough to catch most severe problems. Normally it's very visible. For example, the complete unit changed or it became much more empty. I can imagine some edge cases where the univariate doesn't change, but the joint one changes, but I would guess it's less likely. So, and most people don't even monitor the univariate one of your input parameters. So start with that. That should already cover like at least 90% of the bugs with the input data. Okay, another question. While the engineering implements the monitoring, are the quality metrics defined as part of the model training and serving process done by the data scientist? So I guess it's debatable who should do this. I guess the person or the people running it. It's part of the typical monitoring and running. So whoever does that. So we personally, we are full stack. So we also implemented the model, we ran it, and we also looked at these alerts. But if that is separate in your company, it would be the engineering. How to decide the frequency of model retraining in a cost-efficient way? Ooh, that's completely out of the scope of this talk, but I can tell you very briefly. We typically ran offline tests, so run with a model of 3 weeks ago, of 1 week ago, and so on, and see how the accuracy or whatever your offline metric is drops. And then you can also run an A/B test if you want. Typically, retraining the model can be less cost intensive than what you save. You have to figure it out. A/B test and before run offline tests. Okay, thank you. Any more questions? I will wait around a bit to see if more questions are coming in, but thank you very much to everyone who is listening. Okay, so looks like no one is asking any questions anymore. Then I will say goodbye to everyone and thank you very much.